There are fewer than 200 machines on Earth that can print the future. Each one costs $350 million, takes over a year to assemble from 40,000 individual components, and requires a team of specialists just to keep running. Not a single one of them exists in China, not a single one exists in Russia. And every advanced chip powering your phone, your car, and every weapon system in the American military arsenal was made using one of these machines. Now picture a map. Draw a circle around one island in the Western Pacific. 23 million people, a handful of fabrication plants the size of city blocks. Inside those plants, 92% of the world's most advanced semiconductors come to life. That island is Taiwan. That company is TSMC. And two nuclear-armed powers have spent years engineering a strategy to either seize it or shatter it. This is not a future crisis. The operations are already running. The intelligence campaigns are already active. The supply chains are already under assault. What you're watching unfold is the most consequential industrial conflict since the Second World War, and it is being fought over something most people have never held in their hands, but cannot live a single day without. Forget oil, forget rare minerals. The real currency of 21st century power is etched in silicon at dimensions smaller than a human virus. Your vehicle carries between 1,000 and 3,000 chips. An F-35 fighter jet depends on roughly 8 million semiconductor components. The banking infrastructure processing your transactions, the grid delivering your electricity, the systems purifying your water, all of it runs on chips. Strip them away and you do not lose convenience. You lose the operating system of modern civilization. The nations that understood this earliest are the ones now moving fastest. Beijing has committed over $150 billion to chip independence and failed. Moscow has weaponized raw materials that feed every fab on Earth. Together, they are executing a pincer operation against the single most strategically valuable company in human history. One wants to own it. The other wants to burn down the order it sustains. And the West is only now waking up to the fact that the clock started years ago. To understand how a single company became the fulcrum of global power, you have to go back to a semiconductor engineer in 1987 who had an idea so simple, it changed the architecture of the modern world. In 1987, the global chip industry operated on a simple assumption. If you designed a chip, you built it yourself. IBM did it. Texas Instruments did it. The Japanese giants Hitachi and NEC did it. The idea of handing your most valuable designs to an outside factory was considered reckless. Morris Chang thought every one of them was wrong. His insight was deceptively straightforward. Chip manufacturing was getting exponentially harder with every generation. The companies trying to do everything, design, fabrication, testing, packaging, would eventually drown under the complexity. A company that did nothing but manufacture, that poured every dollar and every engineer into perfecting fabrication alone, would compound its advantage year after year until nobody could catch it. 35 years later, that thesis has proven correct beyond anything Chang himself likely imagined. TSMC's dominance is not a product of money. It is a product of time. 3 decades of iterative process refinement, thousands of engineers trained in proprietary methods that exist in no textbook and no patent filing. Yield management capabilities so far ahead of any competitor that the distance cannot be closed by writing a check, no matter how large. Intel, once the undisputed king of American chipmaking, now sends some of its own products to TSMC for fabrication. Samsung trails meaningfully in cutting-edge capability. China's best manufacturer, SMIC, has been verified producing at 7 nanometers in extremely limited volume, with yields reportedly far below what commercial customers require. TSMC is producing at 2 nanometers and developing processes beyond that. The gap between 7 and 2 nanometers is not incremental. It represents roughly a decade of technological distance. The machines that make this possible, ASML's extreme ultraviolet lithography systems, are engineering marvels that border on science fiction. They generate plasma by firing high-powered lasers at droplets of molten tin falling inside a vacuum chamber, producing light at a wavelength of 13.5 nanometers. ASML spent over 15 years and billions developing this technology. There is no second source, there is no alternative. Every chip at 5 nanometers, 3 nanometers, and 2 nanometers anywhere in the world was printed by an ASML EUV machine inside a TSMC facility or one aligned with the Western supply chain. If you are beginning to see why control of this ecosystem is worth more than any oil field or military base, you're seeing exactly what Beijing and Moscow see. And if this kind of analysis matters to you, hit like and subscribe, because what comes next reveals just how far 2 superpowers are willing to go to exploit the vulnerability we just mapped. Here's the part that transforms this from a business story into a geopolitical emergency. Beijing's awakening was violent and humiliating. In 2019, Washington cut Huawei off from TSMC's advanced nodes. Huawei had been China's crown jewel, a global force in 5G equipment and consumer devices that Beijing had spent decades cultivating. Overnight, its flagship smartphone line collapsed. Sales cratered by over 60% within 2 years. The message was surgical. We control the tap, and we can shut it off whenever we choose. For a government that considers itself destined to lead the world, that was not just a commercial setback. It was an existential revelation. Xi Jinping declared semiconductor self-sufficiency a matter of national survival. The state poured tens of billions through the National Integrated Circuit Industry Investment Fund into domestic champions. SMIC received virtually unlimited resources. And yet, China remains trapped. It cannot close the manufacturing gap without TSMC's equipment, TSMC's processes, and above all, TSMC's people. So Beijing pivoted to a strategy with two prongs. The first is extraction. Thousands of Taiwanese semiconductor engineers have been recruited to the mainland with salaries doubled or tripled, signing bonuses, housing, and research funding. Talent recruitment programs explicitly target specialists in advanced node fabrication. Taiwan has prosecuted dozens of cases of engineers transferring process technology to Chinese entities, but security experts believe far more go undetected. This is not competition. It is the systematic harvesting of irreplaceable human knowledge that lives not in manuals, but in the hands and instincts of the people who built the industry. The second prong is military, the largest naval expansion in Chinese history. Hypersonic missiles engineered to neutralize American carrier groups, hundreds of thousands of troops training for amphibious operations. This buildup is not simply about reclaiming a province. If China takes Taiwan, it takes TSMC. And if it takes TSMC, it captures the nervous system of every advanced economy on Earth. Every Western weapon platform, every AI project, every data center running the financial system of the free world becomes dependent on chips manufactured under Chinese authority. Meanwhile, Russia plays an entirely different game. Moscow does not want to own TSMC. It lacks the talent pipeline, the industrial base, and the strategic patience. What Russia wants is to make the Western order that TSMC anchors so fragile that its existence becomes a liability. Start with raw materials. Neon gas, critical for lithography lasers, was sourced roughly 70% from Ukrainian industrial plants. Russia's invasion severed that supply. Spot prices exploded by over 500%. Russia also dominates global palladium production, controls significant titanium reserves, and produces specialty fluorine compounds essential to chip etching. These are not commodities. They are instruments of economic warfare, and Moscow has demonstrated repeatedly through its weaponization of European gas supplies that it will use resource dominance without hesitation. Everything I have just described is the groundwork. What connects these two strategies into something far more dangerous is a level of coordination that Western analysts were dangerously slow to recognize. Russia and China are not running parallel campaigns. They are running a joint operation with divided labor. Russia attacks the foundations, raw materials, energy systems, supply chains, and the political will that holds the Western alliance together. China attacks the crown, TSMC itself, the engineers inside it, and the island beneath it. Russia feeds China intelligence on Western political fractures and supply chain vulnerabilities. China feeds Russia access to technology that Western sanctions were designed to deny. Neither could execute this alone. Together, they are dismantling the architecture of Western technological supremacy from both ends simultaneously. The coordination extends into domains most people never consider. Chinese entities have been systematically acquiring minority stakes in companies that produce the specialty chemicals, rare earth processing, and precision components feeding the semiconductor supply chain. Not through headline acquisitions that trigger regulatory review, but through layered networks of intermediaries, offshore holding structures, and joint ventures designed to stay invisible. Hundreds of individually minor positions that collectively deliver strategic leverage equivalent to any single blocked megadeal. Then there is the cyber dimension, already fully operational. Taiwan's government networks and industrial systems face continuous, sophisticated intrusion from actors consistent with Chinese and Russian state sponsorship. Groups linked to China's Ministry of State Security have been documented attempting to penetrate TSMC's systems to extract process chemistry data, equipment calibration parameters, and photomask designs. In 2019, a malware attack temporarily shut down 3 of TSMC's most advanced fabs, costing an estimated $170 million and providing adversaries with detailed intelligence on network architecture and response capabilities. Russian state groups, Sandworm and APT-28, have demonstrated in real-world operations the ability to corrupt industrial control systems identical in class to those running semiconductor fabrication. The attacks on Ukraine's power grid in 2015 and 2016 were not just geopolitical messages. They were capability demonstrations that every fab operator on Earth was forced to take seriously. Here is the question that sits at the center of everything I have shown you. What happens if a truly successful cyber intrusion corrupts TSMC's manufacturing controls? subtly enough that defective chips pass initial testing, ship to customers, integrate into systems, and fail catastrophically months later. Inside cardiac devices, flight control computers, electrical grid management, or missile guidance. The damage would be invisible at the point of manufacture and devastating at the point of failure. That scenario is not hypothetical. It is the one semiconductor security experts discuss behind closed doors and that almost nobody is addressing publicly. Where do you think this ends? Drop your analysis in the comments. Some of the sharpest thinking on this channel comes from you. And this is where it stops being about institutions and strategy papers, because the consequences of what comes next land directly on the systems you depend on every single day. The Western response exists, and it is real. The CHIPS Act committed $52 billion to domestic manufacturing. TSMC is building in Arizona. Intel is expanding in Ohio. Samsung is constructing a facility in Texas. But semiconductor fabrication operates on timelines that no political announcement can compress. The Arizona plant has been delayed repeatedly. The most advanced chips TSMC produces today will not roll off any Western production line for years after they enter high-volume manufacturing in Taiwan. The engineering talent shortage is structural. Decades of underinvestment in semiconductor education, a cultural gravity pulling top graduates towards software instead of the punishing disciplines of fabrication physics. Building a genuinely resilient supply chain is a 15 to 20-year project. China and Russia are counting on exactly that mismatch. The alliance system holding the chip ecosystem together is itself a target. This supply chain is not merely commercial. It is a geopolitical architecture disguised as a market. TSMC fabricates in Taiwan. ASML builds lithography machines in the Netherlands. Design software comes from California. Silicon wafers come from Japan and Germany. Specialty chemicals flow from suppliers across 4 continents. The entire system functions because these nations trust each other not to weaponize their irreplaceable positions. Every time Russia engineers a European energy crisis that tests Atlantic solidarity, every time China applies economic pressure on South Korea, who's Samsung, and SK Hynix are critical players. Every time Beijing leverages its dominance over Southeast Asian supply nodes, that trust erodes. South Korea remembers 2017, when deploying an American missile defense system triggered an unofficial Chinese economic siege, costing Korean companies an estimated $15 billion. Japan joined export controls in 2023 at genuine commercial cost to its own equipment and materials firms. The Netherlands restricted ASML sales under persistent diplomatic strain. Every one of these allies is under continuous, calibrated pressure to fracture. And yet Beijing may never need to fire a shot. Gray zone operations, economic blockades that stop short of legal warfare, precision cyber attacks on Taiwan's power grid, sustained military exercises in the Taiwan Strait, can hollow out confidence in Taiwan as a production base until TSMC's own customers begin diversifying away, slowly draining the economic foundation of the very dominance China seeks to capture. So, here we are. The machinery of the modern world funnels through a single island protected by alliances under stress, defended by industrial policies, still years from delivering results and targeted by 2 powers executing with a patience and coordination that democratic systems find structurally difficult to match. The old map of power was drawn in military terms. Armies, navies, nuclear arsenals. The new map is being drawn in silicon. Nations that lose control of this infrastructure do not simply decline, they become dependent, subject to decisions made by whoever holds the technology they cannot replace. Remember those 200 machines we started with? Fewer than 200 devices on the entire planet capable of printing the circuits that run civilization. No substitutes, no workarounds. Every one of them exists within a supply chain that 2 determined adversaries are working daily to compromise, capture, or destroy. The Silicon War is not approaching on some distant horizon. It is here. It is already being fought across every domain that matters. And its outcome will not reshape the next decade. It will define the next century. The only variable still undetermined is whether the people whose lives depend on those chips, which is everyone watching this, will understand the stakes before the window to act closes for good. The empire is not falling. It is being contested. And the battlefield is smaller than a fingernail.